The Frank G. Zarb School of Business and WRHU-FM Radio Hofstra University invite you inside the Z-Suite.
Hello, I'm Janet Lenihan, Dean of the Frank G. Zarb School of Business at Hofstra University. Welcome to Inside the Z-Suite, featuring current topics and talks with business leaders across every industry. In this episode, we're diving into a topic that touches many aspects of our lives: how artificial intelligence, or AI, is making significant decisions in areas such as healthcare, hiring, finance, and our legal system. How can we ensure that the information is accurate, fair, and unbiased? How can we automate processes while protecting privacy? Joining us is Dr. Hafiz Asif, Assistant Professor of Business Analytics and Information Technology at the Zarb School of Business, whose research focuses on building secure, fair, and equitable data systems. His recent work included 2 groundbreaking studies on how missing data can silently bias AI models and how federated learning can help fix it without compromising privacy. In this episode, we explore how data gaps, trust, and machine learning intersect in the real world, from hospitals to hiring algorithms. An expert in AI ethics and data science, Dr. Asif will help us better understand the application and safeguards of emerging technologies and their influence on the way we live, learn, and work. Hafiz, thank you so much for joining us today, and welcome inside the Z-Suite.
Thank you for the invitation. I'm really looking forward to having this conversation. I think this is an important topic, and thank you for having me here.
It's so critically important. And so before we really dive in, let's kind of lay the groundwork for today's discussion and take a little bit of a broad view. So you study, as I said in the introduction, how AI systems are built and how they behave once they're deployed in the real world. From your perspective, what are some of the biggest misconceptions people have about how AI actually works and what it takes to make these systems fair, trustworthy, and effective?
I think especially given the recent revolution, if I might say, that we are seeing in AI world, the biggest misconception that people have, they think that there is a specific set of rules in computers that are there and running, and when they're making decisions, they're just like following that, like you have a rule book. The truth cannot be farther from that. This is actually one of the biggest challenges in responsible AI, what we call explainability, that these models, the way they make decisions, we have no idea. We have really no idea. So they are considered black box in this nature, that there's a huge complex network of equations that we know how to solve. And at the end, you get some answers. But we don't really know what they mean and how they work in a way that we can explain them. So I think this is one of the bigger misconceptions that comes across almost every single time I have a conversation with somebody.
Absolutely. And so I know in your work you use the term safe AI, SAFE AI. What does it stand for, and why do you think it's so important?
The terminology I came up with, I think, when I was finishing my PhD. My primary work, when I started my research, started in privacy. And as I looked into the related problems, I started to realize that the privacy by itself cannot account for all the major issues that we're going to have once we deploy these systems in practice. They need to be trustworthy. So if they make decisions about you, you can be sure that you can trust them. If you do not trust them and you have a disagreement, you can bring about accountability, that you can go and audit those systems and audit those decisions, and you can see how that becomes difficult if you can't explain where this decision is coming from. And since we are talking about decision making by machine, so if a human makes a decision, they are held accountable if they discriminate against you, let's say in regards to protected classes. What if a machine makes a decision about you and then the machine is biased or makes a discrimination? I think the same type of things apply there. So safety is one way for me to kind of put all of these important pieces together, that none of them can be looked into it or can worked on in isolation. We have to look and work on all of them at once. So this kind of alludes to the comprehensive approach that we need in this area.
SAFE, is it an acronym?
Yes. As for safety and privacy, A for auditability, F for fairness, and E for equity. That was my way to remember how many pieces there are.
So it's frightening that we don't have any explainability. And to your point, if you can't explain it, you can't audit it. Can you give us an example, maybe an everyday example of where AI might fall short on fairness, especially in maybe healthcare or banking? Give us an actual concrete example.
Actually, this is very important. I'm really glad you asked this question. Actually, I think in 2019, there was a study published in Science, and this was about a system that is commercially used in the US, in hospitals and insurances. And what they do, they provide patients information into the system, and the system provides a level of risk that they have in terms of their health. So if you are higher risk, you would be provided with better or more resources so that you can be taken care of. And if the risk is low, so, accordingly. However, what they found out in this system, Black individuals and white individuals who have the same biomarkers and all these data points that we use to measure how well an individual is doing. So the two people who have the same health profile, but Black people were given smaller risk and white people were given higher risk. So this is the kind of biases that can show up. They show up in terms of race, age, financial health, like in terms of your economic strata. So they are kind of inbuilt into all sorts of these protected classes.
And have huge implications. I mean, in that example, in terms of treatment. So if somebody was erroneously labeled as low risk, they're not going to have the same access to care.
Exactly.
Just incredible, really incredible. So in your first paper, you focused a lot on missing data, which I have to tell you, I don't think many people realize that often there is data that's missing and the organization finds a way to just fill it in for the model. And so this can seriously impact fairness in your example, not only along, racial differences, but age, gender, and the like. And so tell us a little bit about why this is really hidden, but yet incredibly dangerous issue in terms of how we deal with missing data.
Missing data is often thought about as something to be rid of, something to be fixed. And what is it that we are trying to fix? What happens quite often when we are collecting information, whether through surveys, through individuals who may be filling in some answers, or we are collecting it through some systems, some machines, or recording them. There could be institutional level assimilation of information as well. Often what happens is we are missing a bunch of pieces of information. Actually, a study found from 1980 something to 2004, they analyzed a whole bunch of reported data set across different journals, and they found out only 30% of them had complete data, which means some information in each of the data set was missing. And what missing here means, one thing could be that a lot of information regarding different individuals wasn't recorded at all. In other cases, some parts of information were missing. For example, if you were filling in a survey, maybe you did not fill in your age. Pregnant women who are depressed and they smoke cigarettes, they would not fill in that information. And if you are not depressed and they smoke, so they will fill in. So there are a lot of individual level characteristics that get involved. So what it boils down to, that there are some pieces of information that should have been there. They're often not there. So this is where missing data comes from. Why it becomes a problem for AI, I think that has to do with how AI works, especially in the current context. So the driver of almost all the AI technologies that we see today is what we call machine learning. So that's a very different way of solving problems. In old days, we used to think, okay, we will hire an engineer or a scientist, and they would write a program for us, and we would just run this program and solve our problem. But increasingly, we realize humans are not as smart to solve all of our problems. The very first field was computer vision. Scientists were spending a huge amount of time figuring out models to detect a face from an image. They had very specific mathematical models. Then came machine learning in the form of neural networks, and it hasn't been beaten since then. Since neural networks, all facial recognition is done by neural networks, in which machine learning is the driving technology. So what happens? You just collect data. For example, here's an image of face, and this is not an image of face. And you have a lot of these images. There's a specific learning algorithm, which is a program written by human. So it's a kind of meta program. So this program will take in all of these images and data, then write a program that once you give an image will tell you whether it is a face or not. So machine learning is this driver behind AI that we are considering. So now let's look at this pipeline again. So now machine learning is supposed to take in data and turn it into a program or a model that will make decisions. But almost all of these algorithms, when they take in data, they expect it is complete, meaning there is no missing information. But what happens when there is missing information? So we need to do something in order to make it work. So that's where machine learning and AI come together.
Does the model fill in the missing data? How does it deal with the missing data? Or is it just ignored?
The next part is then how do we deal with this missing data? Primarily, there are two ways. One is you can drop any of the information that has any part missing. The other one is you can impute what we call those missing values, that you can put in some value that makes sense. For example, you can replace it with the most common value, or you can replace it with an average, or you can use more sophisticated models like linear regression or neural networks or other machine learning approaches to learn models that would replace those missing values with some reasonable values. So deletion, like removing all the data with missing values, is one strategy. And the other one is imputing those values. And this is how we make the whole machine learning pipeline work.
Can you give us examples? Because I think it might help for non-technical people like me, where missing data might unintentionally lead to an unfair or biased decision.
If you are coming from a particular group, you may not be trusting a particular institution that you are going to, and you choose to not give that information. Or you may have privacy concerns and you, again, choose to not give away this information. You could have institutional processes that are systematic, maybe bad reporting, shortage of staff, erroneous reporting, that can all lead to these type of missing information. Now, when missing information is tied to what we call sensitive attributes, like protected classes, what happens is some groups would have more data missing probabilistically than others. And when we're going to go and impute using general methodologies, what happened, we try to bias the group whose information is missing more from the information of the group that was not missing. And that leads to decisions that are biased. For example, if we are talking about loan approval, the bias will show up there. If you're talking about the risk assessment, the bias will show up there. Because at the end of the day, those imputed values, those replacement values are biased by the group whose more information is there.
And oftentimes the group who has more information, right, is not necessarily a traditionally underrepresented group.
Yes, that's a very good point. It depends. So in our research, what we realized that there are two ways to look at it, like two dimensions. One is, are you a majority or minority group? And then the decision that we are interested in, let's say positive or negative. So it's a combination of you're a minority and the decision about you is positive or negative, or you're a majority and the decision about you is positive or negative. So if you're a minority class or your positive decisions are missing, for example, a minority class whose information was missing and also the data points were missing that were about not defaulting, then the decision gets biased against you. It is a very good example in the sense that your information not being there is causing harm, not just to you, but a community at large. This is some of the ways it kind of comes about.
Just fascinating. So in your work, you talked about federated learning. Sounds super technical. What is it that people should know about federated learning?
Federated learning has become very big, and I think increasingly being adopted by industry, academia. There are a bunch of government consortium, industry consortium that are coming together to create such federation. And what it essentially is, you have different organizations or individuals that have their data, either on their data stores or their devices. We consider this information to be proprietary, sensitive, or confidential. We are in Industry 4.0 and data is the new oil. So everybody understands how valuable this information is, and nobody, even if it is not sensitive, for value purposes, people do not want to share their data. And on the other hand, we see that by increasing the amount of data and by increasing the sizes of our models that we get from machine learning, we are able to do impressive things. As again clear by what's happening with large language model, it is a combination of huge models and huge data that are able to solve some really, really difficult problems. Federated learning allows people to, or organizations, to keep their data in their own silos, in their own machines, and never share raw data. But what they can do is locally build some models then they can aggregate them at a central facility. A simpler example that I can think of, it would be, imagine if you had hospitals, and different hospitals have their own data. They are geographically separate, serving different types of community, different types of ailments. But each one has a part of the picture, not the complete picture. The complete picture comes when we put all of the data together. However, privacy concern, privacy laws, regulatory compliances, all of this will come about, which will become a hindrance towards putting all of this data together. So what can we do? Federated learning. They can learn a linear regression model in each of the facility, and then they can release that local model to central facility. So this is just a average relationship in the data, not any particular data point. In federated learning, we can aggregate these local models into a global model that leverages these global insights from all the parties without ever exchanging actual data points from their databases or from data storage. So that's what federated learning has been able to do. NIST is running program. I think NIH is running program. Google, Apple, they have all sorts of their other programs in which they've been able to use this technology to do impressive things. If I remember correctly, one of the very successful project was done by Google for keyboard word prediction. This is a very personal thing, what you write on your phone, and you don't want to give it to a company, right?
Very true.
So they use federated learning to learn a model about word prediction so that autocorrection can be made better.
You know, when you can see the application, I'm just thinking of insurance industries.
Yes.
I mean, my gosh, if they were able to do this federated learning, they could actually create models that are much more accurate in terms of risk assessment for different behaviors and insurable risks.
True. That is true. And that's why federated learning is very big. Even some of the national research labs in the US, they have dedicated programs and systems where they are building these next generation federated learning solutions and frameworks.
So does federated learning help with the missing data issue?
That's what CAFE is kind of arguing for.
So what's CAFE?
Because of the value of data or regulation, the data is being siloed when we want it to share. So when it is siloed, we can use federated learning to combine them virtually and do predictions or better predictions. The other side of federated learning is because it is machine learning, you still have to have data that goes into machine learning algorithm, and then you churn out a model that will make some decision. But if your data is missing, then you need to do, again, an imputation. Now, one way to go about it is that every party locally can impute their data using their own knowledge. Then they can carry out the federated learning process. But what happens is that there are many scenarios where different organizations have different types of missing data. So let me explain with an example. There's a hospital in Newark, a hospital in Hampstead, Long Island, a hospital in Greenpoint, Brooklyn. They serve very different type of ailments and different types of people. Not just that, but also the relationship that the individuals have with their institutions is also different. So this leads to phenomena that I was talking about earlier, that how individuals may not trust or try to avoid giving some information. So this creates what we call heterogeneity in terms of what type of information is missing in different institutions. So the question becomes, okay, we have, let's say, these 3 hospitals, each one having different type of information missing. Is it possible that we can use observable information in one to do a better imputation of the other? Because these are very heterogeneous situations. There's no one solution fit all. But what we can do is learn from others what we don't know about ourselves and use that to do a better imputation model. And that's exactly what CAFE does. CAFE takes this federated learning framework. It turns it around in the following manner. Instead of learning a global model from all these local models to serve everyone, it says, I am going to take insights from the global to help one individual. So each individual party is using those insights from other parties to do a better imputation. So we have this idea of complementarity that, we want to be able to measure how different somebody else's data is from you. If they're very similar, that means you have similar type of data or similar type of missingness. If they're different, then maybe you have something to contribute to that I don't know about my data and it can help me. So CAFE is able to do what we call the next level of federated learning, personalized federated learning, in which we use global insights to cater for each individual party independently.
And would that then in turn make the model even smarter? Because if I'm filling in the missing data now with data that I was able to capture from another source, right? And I fill it in, then I send it back out to that global federated learning.
Exactly.
Is the model smarter?
Yes, the model is smarter. Model, I would argue, is also fairer because, as I said, like the Greenpoint, Hampstead, and Newark has a very different demographic, like extremely different demographic. And you would see that by combining this, you have been able to come up with a sample that is more representative of what the global population looks like that we want to serve.
That's just so fantastic. And, I think what's so really interesting about your work is it focuses so much on trying to build AI systems that reflect the human values that are so critically important to us as a society, like fairness and transparency and privacy. But technology is moving so fast, coupled with the fact that there's not a lot of human oversight that's able to keep up with the technology as quickly as it's advancing. True. And so how difficult will it be, do you think, to embed those values that clearly you're researching, right, and that are so important to our society? How difficult will it be to embed them into AI and to modern AI systems as we continue to emerge along this line?
Janet, this is a very challenging and exciting time. So I remember when I started working in this area, I was an undergraduate student, and I was taking a grad class on computer system security. In there, we were studying a research paper in every class. And I came across this paper, which was about what we call private set intersection. You have some information, and I have some information, and we want to figure out if we have something common. The question was, can we do it without ever revealing what information you have and what information I have? And the answer was yes. And the way they did it blew my mind away. This is in 2013. Since then, we have come a long way. Like, it was a toyish example in some ways that I was studying about and was excited about. From there to today, as we have been discussing, even in this conversation, that how deeply embedded in our general frameworks of organizations, operations, logistics, decision-making AI is. It has become a big challenge, an impactful area in that kind of way. What gives me hope is that there is a lot of effort going on right now and since then, right? So those are the reason I mentioned, because there are individuals and research groups and people who've been thinking about this problem and working in some kind of capacity. So we do have some solutions that we know work and how we can use them to use AI in a responsible way instead of a solution approach first. However, this has to be enforced or adopted in a way which is not clear to most of us. For example, there were about 350 consumer privacy bills just in 2023. 550 bills on AI-related bills have come out again in last year. So there's a lot in regulation that is going on. There's a lot in application that is going on. There were about 3,000 papers in 2023 around these topics. So there is a lot that is going on, but what is not clear is how we, in the society, in industry, how do we go about doing it? Do we do innovation first and risk assessment later, or we do risk-based implementation and management? NIST has come up with a framework that they did some finalizing touches in 2023. It is an AI risk management framework. There are others. So as you can see, my answer is scattered. It's for good reason. We do not have a clear answer. It is important to do risk assessment and management. Without it, we can really cause serious damage to our society. For example, the latest version of ChatGPT was reversed. I don't know if you know about it, because in lighter terms, ChatGPT was a suck-up. It was it was flat.
Very technical term.
Yes, very technical term. A non-technical term is called sycophantic.
Suck-up is better.
Yeah. So it was flattering and agreeable. And the kind of media we produce for our masses, we can imagine that going forward, a lot of synthetic media produced by AI would be floating around. We won't be able to distinguish in many capacities what is human and what is computers. Old problems of propaganda, biased information, what is the truth, all of those things become very kind of central. So I think we need to exercise caution, and policymakers and the technologists have to come together and take an approach that takes into account the risk and the safety measures before they start doing deployments. So that's where I come from.
Hafiz, it's so critically important. Who needs to be at the table in those conversations? Is it just technical people, or should others be involved in the conversations as a society as we think about how do we regulate
Janet,
and ensure fairness?
This is one of the most important questions. I think the answer is very easy. We have known problems only engineer and data scientist approach has created. I'm sure you know about Google captioning fiasco, Amazon recruitment bias, Facebook filter for trending topics, and the list goes on. The people who need to be at the table, we need to have all the voices about whom we're going to make decisions. In addition to the engineers, we also need people who understand and have studied these systems not by their technical implementation and deployment, but rather there's first and second order impacts on society. So sociologists, socio-technical system experts, because at the end of the day, it's not the computer by itself. It's going to be the computer with human beings and then they interacting with them and the kind of loop that we go on. In addition to engineers and scientists who are developing these systems, we need people, representative of the individuals about whom we make decisions, and experts who have understanding of socio-technical systems and their impact.
For the business leaders that are listening today, what should they be thinking about when it comes to data in their own organizations, platforms, and AI systems that they're building? How can they ensure they're building fairness into those models?
Today, AI tools have become very, very, very accessible. Anybody can go on and build a model. You have some data. I think the analogy is like if you see data, the ML is the hammer, so you can just do drag, drop, churn out a model. And a lot of individuals and companies are doing that. However, the kind of impact, negative impact that we would be creating for our society, but also the impact that would then come to your organization is going to be very, very expensive and damaging. When they are collecting data, I think the one thing would be how representative it is. Restricting your decisions to the kind of population you serve, you have data for, is one way to avoid a lot of problems. The second is now the field is mature a little bit. So there are metrics on which you can measure your decision models to see what type of biases are there and for what groups you see those biases. So one of the ideas that I have been discussing in my research group is maybe we should decide not to make decisions about the groups that we don't have enough data for, because that is the question about generalization. So like either we make an implicit or explicit assumption and state it that, although my model may not support this and I make decision, then you become culpable if there is a bias. Otherwise, I think just kind of hodgepodge of I have some data, I have some algorithm, and I churn out a model to make decision. That is going to be a very damaging approach. As I said, there are 550 bills or more coming. It will cause a lot of trouble for businesses if they do not take a proactive approach about making sure the decisions are fair, that they are doing sufficient precautions and taking measures to ensure privacy, not only in terms of like protecting their data within their computers, but also the kind of models they build, what type of information they may be leaking about their customer or their own organization. So these are some of the things that can be helpful.
I think that's really great advice. When you think about those 500 bills, the truth is the technology is changing so quickly that those bills are probably not able to keep up. And when you say we came a long way in 12 years, just imagine how quickly these technologies are changing. We're at the point in our interview here at Inside the Z Suite where we'd like to ask our guests some very fun questions that I just want you to answer off the top of your head. Are you ready?
I think so. Let's start.
All right, terrific. If you could trade places with anyone or anything, who or what would it be?
Mickey Mouse.
I love it. Why not?
It's easy. It's fun. It's fantasy.
Happiest place on earth, Disneyland, right?
I do not find real world as amusing as Mickey Mouse.
Terrific. What is your favorite household chore?
My favorite household chore is cooking.
Cooking. Excellent.
On Thanksgiving, I made 2 turkeys and a dinner for like 15 people.
Wonderful. I'm expecting my invite because I like to eat. What is your least favorite chore?
Doing dishes.
True. They're never ending, right? Final question. And this really is for the students who are listening in the audience. What is the key to success?
Learning from your mistakes and being persistent. Mistakes are there so that we can learn. In my classes, whenever I'm teaching AI, and I'm kind of making sure this point is conveyed to all the students, do you see how we are making these very smart AIs? It's just a basic thing about reward and penalty. Penalty for kind of mistake, that they make, reward for the things that they do right, which essentially boils down to that they are learning from the mistakes that they make. So this is the same approach that if they adopt, like learning from the mistakes rather than being discouraged by them, I think they would have a superb career and awesome life ahead.
Well, that is such wonderful advice. Hafiz, thank you so much for being with us today, for sharing your insights and helping us better understand the powerful ways AI is shaping our lives. As the saying goes, AI doesn't remove bias, it automates it. And without thoughtful, human-centered design, we risk not just repeating existing unfairness, but embedding it into systems that operate with little oversight. So, Dr. Asif, we appreciate your work and your commitment in making AI more fair, transparent, and accountable. Thanks so much for being here.
Thank you.
Be sure to tune in weekly on the radio and online to WRHU 88.7 FM, Hofstra University, for a new episode of Inside the Z-Suite, or catch up with our show wherever you enjoy your podcast. For more information about this program and the Zarb School of Business, please visit hofstra.edu/business. Until next time, I'm Janet Lenihan from Inside the Z-Suite.